Okay, so for this lecture, we're going to quickly go through some of the visualization. We have covered how you can filter the data, filter any image collection, and then also filter vector data. And by now, you should feel comfortable of if I ask you to give me some data for a specific area, for a specific time period, you should be able to do that. So this is kind of equivalent to the past. You go online to the USGS data portal, select the country you want, select the state you want, and then filter out the date, filter by cloud cover. So there's basically filter doc something, filter bounds, filter dates, and then filter by metadata. Okay, so after you have some kind of this data, you might want to visualize that. So the easiest way is just to use the map.add layer, so it should be able to handle any feature collection. So this one here, for example, is the US states feature collection, right? So you create a map, and then you point to this feature collection, and then just add that. By default, it's using the curly brackets. So basically, you don't provide any visualization. So by default, you'll be the black outline and then 60% transparent in the middle. Okay. So this is the way you want to add if you want to inspect the attribute. Okay. Otherwise, later for other methods we're going to show you, it's going to convert the vector into JPEG or PNG, and you cannot use attribute anymore. So usually this is what I want, right? So in here, you can click and then see what kind of column of the attribute. At least if you want to do the filtering, then you can get the name of the column and also the value. Next way, I think I'm going to skip the second one. This one is not very commonly used now. So this is the way that you might want to use. So here, you will see the source code is the same as the previous one, except now we add this style. Okay, so the style function means you want to style this feature collection based on something you do. And if you don't know what to do, you can always go back to the again where is it here, and go to feature collection, and there's a style function. So I'm going to scroll down to the end somewhere here, right? Style. And this one here shows you all the parameters you can customize. So the style, you can doc style, and then color, point size, shape, width, fill color, style property, neighborhood, line type, something like that. And you can look at the example here. It's actually pretty good. Like give you all the things. For example, power plant. Let me see if this. Let me see if I can show you. This one is a bit complicated, so the automatic conversion might work. But let's give it a try here. Copy this one. If it doesn't work, we can try the other example. Okay. Okay. All right. And then Control C, Control V. Go here. Maybe create new one. Yeah, this one is a bit complicated. Yes. Anyway, I don't waste too much time here. Let's focus on this one. So, like I said, there are parameters allow you to do customization. So, where's it? Here. So this is the line, and so what you can do is instead of just adding a variable, now we're adding a style. So keep that in mind. The style means you have the feature collection. Think about like ArcGIS, right? You open the original data and then you can click it. And once you change the symbology and other stuff, it becomes a style, becomes a raster. So it's not a vector anymore. So the style function is turning the feature collection into the vector. And then style, inside layer, you have this two star. So this actually is a dictionary. So it basically unwrap the dictionary, turn it into something equal to something. Okay. I think it might be a bit confusing, so I can show you the differences between this, especially if you're new to Python programming. This is probably hard to understand, but let me comment out this line. Okay. And this is basically, what is this doing? It would be, what's that? Color equal to this one. See if it works. You see? So doc style, within there, you can provide the parameters. So the parameter Python usually will be the name of the parameter equal to something. So what I need to do here, basically, will be this comma, and then because right now it's all blue color. Okay, so the color here is 8 digits. Okay, the hex color code 8 digits. So that means it's RGB. The last 2 digits are opacity. Okay, so if you look at this one, R is red is 0, green is 0, and then blue 255. So it's going to be pure blue. Also, the last two FF is basically the opacity. So right now it's FF, that means it's fully opaque. If you want to make it somehow transparent, you can change it to other number. If it is 00, that means it's going to be fully transparent. So if I do this, probably the map is going to be, you don't see the, oh, here, I should change here, not the above, because I already commented out. So 00, it should be just transparent. You don't see the data layer. So I can change it maybe usually to 80. It's roughly half transparent. Take a look, right? So means right now the color is a little bit transparent because of this. You can also, change the fill color. So if you want the color to be something else, I can say fill color equal to the same thing. So what color do you like? Green. So what's green hex code? 00 FF 00. So the last 2 digits, if you don't fill it, it should automatically FF. Okay, so I can maybe do FF and take a look. So now it should be like dark color, blue color outside, and then green, fill the green color. Right. So if you want to be somehow transparent, you can change it to 0 from 00 to FF. So FF is 256. 00 is from 0. So it's hex code. So somewhere in the middle is around like 80. So 80, I think it's 88 or something. So I would say 88. Then it will be 50% transparent. So basically half transparent. So now you can see this data layer come from Google, the data Google Earth Engine, and if you turn off the map, it will be just like this, right? So this is how you actually change the style. And as I said, if by calling the function, you can do this way. Something equal to something, basically the parameters. Or you can do it this way. You can define a dictionary just like this. The key, the value, the key, the value. And then if you have 2 star, 2 star, it's essentially unwrap the dictionary into something equal to something, comma, something equal to something. Understand? So if I come back to here, let me see if I can just print out this one. Yeah, it doesn't work. So the 2 star is unwrap the dictionary and then change it to the form of key equal to value, comma, key equal to value. So this is usually what I would do rather than having here something equal to something, comma, something equal to something. It's going to become very long. So the line will be very long. It's not, doesn't look good. So this is the better way. Okay, define a dictionary, key value, comma, key value, and this is all you can customize. Okay, and then just call the style. Also, this one you don't provide anything in the parameter. So you're turning the feature collection into a raster and then just visualize. Okay. So here I run this one again. So right now, if I ask you the question, I want to create a US state map, and then with the outline is black color, and then fill with light blue. Can you do that? Black outline, light blue, half transparent. What do I need to do? So what do I need to change? Color? And what's this be? Dark color. FF, 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 and then FF. Oh, but you can have 6 as fine. And then what else? Fill color, I would like light blue, for example. Yeah, light blue is fine. So what's light blue? 0, 0, 0, 0, 8, 0. Okay, so if it's dark blue, it will be FF, right? So somewhere in the middle, light blue, maybe FF. And then if half transparent, I can have another 80. And it should get close to something you want. You can always customize it. Oh, what? Oh, the color is doesn't. Oh, why is white? Oh, dark is 00. If F is all white, if you have all the color, then it becomes white. So if you want a dark color, you should be just 60, okay? And then FF, now it should be dark color, right? So you can, you can play with this. Also the line type, right now is using solid, right? So how about I just want the dash line along the border? And we do that. We come back to here, line type, widget here, solid, and you can solid, dotted, or dash. For example, I want the dash. Come back here, Control C, and just change this one to dash. Use a dash line. It might not be very clear. Okay, what happened? Something wrong? Yeah, you can see that at the top here. It's not very clear, but if you have maybe used the dotted, D-O-T-T-E-D, it'll be more clear, right? Now you can see the line, or you can just turn off the color so that it's very clear. You can just change it to 0, 0. See? And this is how you can customize. So you can play with it. Just use whatever parameters this provided, and you can oops here. View color style property. So the style property allow you to style by an attribute. That one is a little bit more complicated. I think I have an example here. I'm going to show you. There's also an X style vector. So this one might also, if you want to use it, it's fine. This is the kind of Gmap functionality, not Google Sensing. So here we create a map, create a feature collection, and here you can tell how you want to visualize each one. Also, the color palette is which column you want to color it. This can be useful if you're doing like population. So if you're trying to create a map that with population range from somewhere to somewhere, and maybe let me go back to the previous one here. See if we have any population attribute here. How about this? Right, there's no population, but there's area, right? Air land or air water. So for example, I'm asking you to create a map of the United States, and then with a color map that can show you the color changes from a small land area to large land area, right? So here I can use this column, A land, okay? No, I'm not sure if you can do that, but let me give it a try here. So I'm gonna come back to this example. Right now it's using the name alphabetically. So it's better probably to just use the lane, okay? So I'm gonna use A lane, and then take a look, see if it works. It may not. Okay, looks fine. Does it make sense? So the color, maybe I'm gonna change to another one. I think it'll be better used. I'd like to use cool one, okay? And then the cool color means lane area is small. It might not work, I don't know. Palette, sometimes you need the least. If it doesn't work, we can change it. Probably it doesn't work. So you do some of the functions for the add layer. Oh, it works. That's good. So take a look, right? So what this one is doing is basically we're adding cool warm, and then based on the column. So we're calling this function add style vector, and this is the feature collection. And then you tell Google Sensing or Gmap what column do you want to use to represent the color, and then it's going to rank the number from the smallest to the largest. You're going to use this color. Also here is the, yeah, I think the visualization, yeah, the visualization controls beside the color what you want for the field color. So look at this one. What does this really mean? So cool warm means cool is like a smaller lane area. Warm is larger lane area. Does it make sense here? Right, so these are pretty much small, and this is large. And this is where you can control create a map like this based on a column, whether it's alphabetically number or it can be values, right? And you can change it because this one here I'm using a field opacity, right? 0.6. I can change it to 1. That means it's going to be fully opaque. So if I run this one again, right? So now you don't see the background because I don't use the it's fully opaque, so you don't see the text beneath. But at least this is some simple way if you want to do create some map. And this is exactly the same as in GS, the crop place map, right? You create a map based on certain column, based on the value. It can be population, it can be area, it can be temperature, it can be anything. And this is what you can do. So maybe in the next quiz, I will ask you to create a map of uh, global temperature by country and create a map like this. Can you do that? Yeah, no, right now this is the attribute based on the already the information already in the column, but we haven't talked about how you can get the information for the imagery assigned to the vector yet. There will be maybe a couple lectures in the next couple weeks, but it can certainly possible. This is more like you can also do zonal statistics. Right? So I give you the country boundary. I want you to extract, for example, the average temperature for every country. And once you have that, you can create a map like this to show, to do classification, right? Or even in the state, right? Which state are very hot, which state are very cold. Ooh, not cold. Yes. Uh huh. Uh huh. Oh, that's the Python basically turning a dictionary, unwrap it, turning it into the form of something equal to something. So like I said here, you'll be equal to something basically. If you don't do this one, you need to write them down here. So you need to maybe color equal to blah blah and then comma. So for example, you'll be like this. Like this. So you need to continue to color equal to this one. Right now, if you just run this, so you'll be just, this is just the, did you? Interesting. Cool, warm. Oh, this kind of default parameters. So if you provide, you're going to replace, these are the default parameters. So what this is doing is to check whether, and this is not a good example, but I'm just saying for this function, if you don't provide the parameter, it's going to use these default parameters. If you provide, you can override, right? So here, for example, I can change to 0, 0, 0 FF. How many F? Right. It should turn to blue color, right? So it's going to replace the parameter. But anything that's star star is turning a dictionary, unwrap the dictionary, turn it into the form of key equal to value, comma, key. This is very common in Python. If you have a long, the number of parameters are very a lot, and then you don't want to just type equal something to equal something to equal, because you can construct a dictionary very easy and it's much easier to read rather than continue to type a long parentheses there. So star star is where you unwrap the dictionary, turn it into something equal to something, comma equal to something. Okay, so this is styling by attribute, and there are more examples here. For example, I can show you. I'm not sure if this one works. Yeah. Oh, for example, I can try to create something for wetlands. This is a bit more complicated, but certainly you can do something like this. And here, right, this shows you the color, a different type of wetlands. And here, let me turn this one off, right? Turn this off. And turn the all off, right? To look like this. So you can create some pretty nice maps, and you can color by attribute. But this is, if you want, you can take a look at it. It's a bit more complicated. So here we are basically creating the type, the laser you want, and also the color. And this is where it is, right? So you can assign the color to different type. So basically this one give you fine control about what you want. The color, the label, the view color, and by default, if not, it's going to use this default color. So this is all from the EE vector style. And so if you have a feature collection, you want to style it by a specific column, and you can provide the list of colors for this list of types and also the color. So this one actually come from the wetland type. Is think about when you open the attribute table, right? There's a column name called wetland type in that column in all the entire feature collection. And within there are different categories. It's actually one of these, right? So if you can find this column, it's going to assign with this color, the first wetland type. The second wetland type is going to assign with this color. So this is what these two are doing here. So tell me which column you want to style. And I know if you already know how many types in there, you can have the corresponding color for each type. And then, so this is kind of similar when you're trying to create a map of, for example, uh, um, high income neighborhood, uh, medium income neighborhood, low income neighborhood, or very poor neighborhood, something like that. And so in your column, you have these values, and then you can assign a color if you want to assign a color to each one. So this is exactly what this is doing here. Have each color and then assign something like that, and then it's going to add uh, A8, basically A8. This is the opacity because by default it's only have 6 RGB. So A8 means they're kind of a little bit transparent. You can certainly change to FF, or if you don't add it, that's fine as well. So if I change to FF, and just to show you what it looks like, oops, then it's going to be fully opaque, so you cannot really see anything beneath the data. I add another laser. But anyway, you can try it out. So this is how, for example, you create the vector data. So this is all the wetlands. So you can see it's pretty good, right? It can have different color, and then also the legend here in the lower right. Basically, give you any vector, you can customize to any way you want, just like traditional GS, but it's a bit more complicated because you need to tell the program exactly how you want. You can give me the column, all the values, give me the corresponding color, and then I'm going to like basically one by one and give you the color. Play with that. Like I said, it's a bit complicated, but once you get used to it, it's pretty easy. So also, for example, for this one, um, I'm going to create, for example, the power plant around the US. No, the entire globe, not just the US. And there are lots of lines of code in here, but take a look, right? Pretty nice, but only a couple lines of code. You have access to the entire vector data, and you can also create the type of power plant field type, basically what is filling the power plant. And this is just using the points, right? And it's at the global scale. It's big. And so what we are doing here is, okay, tell me what column that has this field type. And then for each field type, I'm going to assign the color. So if you go back to the example here, these are the field type is a list. And then this is the corresponding color. Okay, so this one corresponds to this one call. The second one corresponds to this. Okay, so just tell me basically a pair of label and color. And then what you want is, you can just get this power plant feature collection, and then you can filter fields one in the list in one of these. So this one, what it's doing is, okay, I want to create a map of all the field type of this one. And then so there are more field type than this. Okay, so the original database has more, probably has a couple more, but I'm focusing on this field type. And then so if the one of those, I select the feature collection, and then I use the gmap.e vector style. I provide the feature collection, and then I tell it I want to fill color by this column, and then provide the label, provide the color, and then that's it. Okay, so just think about the logical steps, what you need to do. Feature collection, select the column, give me the corresponding what you want to filter. If you don't, you're going to add all of those. So right now you see a bunch of all the colors in here. It's pretty good. But you can customize it. For example, I just want to focus on maybe just the coal, oil, gas, maybe just 3 types. So, okay, you can certainly do that. I can remove all of these. Right now, I can focus on just 3. I can remove this. This 3 here, 1 to 3, 1 to 3, and then running again. Now it's only have 3 types. Take a look. So the corresponding, the laser here, I have 3 columns, and this is basically you are filtering the data, and then you are creating a map of the data. Okay, so now you should be able to do any vector data. So if I give you any vector data, you can easily do the cast, select the data you want, and then give the data whatever you color using some of these functions. Okay, so we are out of time, and that's all for today. Run the example. So next lecture we talk about how to filter the data, how to source the data. Make sure you practice, and be prepared for the quizzes at any time. Okay, I will just give the quiz randomly throughout the semester. Any question? Let me know. Otherwise, see you on Wednesday.